So today we're going to talk about our final lesson on annuities. It's basically just rearranging some of the formulas that we've seen before. So just to kind of recap, we've solved essentially future value annuities was our first lesson, and present value annuities was our second lesson on annuities. So when we think about future value annuities, we want to think about us not having anything and then putting regular payments into something, and then having a sum at the end. So if I'm saving for my kids' post-secondary education, I'm starting with nothing. I open up an RESP account, registered education savings plan, and then I put money into it monthly. And then I have some kind of lump sum that we can use at the end when they're in their post-secondary education. Did you ask your parents if they have one of those for you or no? You should ask them. And then the other option is we have some kind of lump sum money, maybe that we can put into some sort of investment, or like we talked about loans. So you have to like pay down something, and then typically you can be paid out later. So like if I have some retirement savings, people usually don't take out all their retirement savings when they retire. They'll take it out month by month as they need it so that the money can continue to earn interest. So something like that. Or maybe you're paying something down, right? Like a loan, like mortgages that we talked about. So those are the two different formulas for that. In either scenario here, we can rearrange these formulas to essentially figure out what the regular payments are for a certain desired amount. So what are my regular payments for a desired future value amount? So if I want to invest something and I want a certain amount in the future, maybe I want $1 million by the time I retire, I can figure out what those regular payments are if I can estimate my maybe projected interest rate on that thing. Or if I have like a certain mortgage or something like that, I can figure out maybe what my regular payments for that mortgage might be. Or if I have a certain amount in my retirement account, I can figure out what my regular withdrawal could be every month based on how much I had saved by that time. Okay, so we're going to take a look at two examples, and then you're going to do some exploring of different types of mortgages. And then there's just a few questions. So we have to decide in these cases, is it like a future value? So is it something projected that I want to have in the future, or is it some kind of lump sum that I have now that payments are being taken out of, or I have to pay down a loan or something like that? So look for those two different types of scenarios. Okay, so Brienne wants to save $6,000 for a trip she plans to take in 5 years. What regular deposit should she make at the end of every 6 months in an account that earns 6% per year, compounded semi-annually? All right. So, actually, we're going to say what regular deposit should she make at the end of every. Oh no, that makes sense. Sorry, I was thinking that these didn't match, but they do. Okay, so firstly, is this a future value or is this a present value? Is this an amount that we want to have in the future, or is this a total amount that we have now? Okay, so we're going to use that rearranged future value formula, this first one right here. And let's write out what we know from the question. So obviously we're trying to figure out R, which is the regular payment that she has to input into that account in order to eventually have $6,000. So future value, what we want to have is $6,000. R, CP, and T all need to be filled in. So what is R? Little r. Yep. Perfect. Compounds. Yep, semi-annually means 2, and then T. No, so she makes the regular payments every 6 months. Yeah, so she's going on a trip in 5 years. Perfect. Okay, so let's plug that into our formula above. So it's future value times R over CP. This is essentially just rearranged from the formulas that we did the past 2 days. And then all over 1 plus R over CP, so 0.06 over 2. And then CP times T, so that's 2 times 5 minus 1. Okay, before we enter this into our calculator, one thing that we might do is just simplify some of the fraction stuff here. So that's 0.03. And then this will be 1.03 to the 10. Okay, so if you're watching the lesson video, you can pause now and do this calculation. Yeah. $523.38. And can you tell me what this represents? Like, what would be your final therefore statement here? Perfect. So therefore, she needs to deposit $523.38 every 6 months to save up $6,000. Okay, perfect. All right, so Donald borrows $1,200 right now from an electronics store to buy a computer. He will repay the loan in equal monthly payments over 3 years, starting 1 month from now. He is charged interest at a rate of 12.5% per year, compounded monthly. How much is Donald's monthly payment? So is this a present value? Is this a sum that we have now, or is this a future value, a sum that's going to be that we have in the future? Okay, so this will be the present value one. So we have present value. R is obviously unknown. That's what we're trying to find, like big R. Little r, CP, and T for this one. So what can you fill in? Yep. Perfect. Great. Okay, so let's use that rearranged PV formula. Here, if you want to look at it, it's right there. All right, so R is going to be equal to PV times R over CP, 0.125 over 12, all over 1 minus 1 plus R over CP, so same thing as we did on top. And then negative CP times T, so negative 12 times 3 in this case. And then maybe we'll do a little bit of simplification here. So I'm going to do the 0.125 divided by 12. Oh, and that's a repeating decimal. So maybe we'll just try to leave it. This we can simplify to 36. And let's try to enter this all into our calculator altogether. Okay, this top thing, we actually probably could just simplify to 100 times 0.125, just 12.5. You get, Gabe? Perfect. Okay, so if we try that in our calculator, we should get $40.14. And can you give me a final statement for this one? What does this mean in the context of our question? Perfect. So Donald will pay $40.14 monthly for 3 years to repay his loan.